Now we have to discuss a few problems from the sampling operation, how to find the Nyquist rate, right, and how to find the Nyquist interval from the given signals. So from the sampling theorem, one frequency condition is defined. That condition is Fs is greater than or equal to 2 into Fm. Right, this is explained from the sampling theorem. The minimum sampling rate is called Nyquist rate. So from this, the minimum sampling rate is Nyquist rate, right. So the Nyquist rate is Fs is equal to 2 into Fm. Here Fm is maximum frequency of message signal. This is maximum frequency of message signal, right. So to find the Nyquist rate or to find the sampling rate, always we have to find the maximum frequency of message signal. First of all, I am taking the message signal is a voice signal. Let us assume here m of t is a voice signal, or we can call it as a speech signal, right. So m of t is a voice signal or speech signal. The frequency range of voice signal is defined from 300 hertz to 3500 hertz. So generally the expected frequency range of the voice signal is 300 hertz to 3500 hertz. So from this, what is the maximum frequency here? 3500 hertz. So the maximum frequency of the signal is now Fm is equal to 3.5 kilohertz, right. And if you want to write the Nyquist rate of voice signal or speech signal, so the Nyquist rate of speech signal is 2 into Fm, that gives the 7000 samples per second, right, 7000 samples per second. This is one of the standard values, so try to remember this value here. Nyquist rate of speech signal or voice signal is 7000 samples per second, and according to this analysis, we can take the sampling rate is greater than or equal for speech signal processing purpose. For speech signal processing purpose, the sampling rate of voice signal is 8000 samples per second. So the generally used sampling rate, this one here, for speech signal processing purpose, right. So speech signal or means if you want to convert the voice signals into digital, this frequency, standard frequency is used, right. So sampling rate of voice signal is how much here? 8000 samples per second. That is defined from the Nyquist sampling theorem, right. And if you want to write the Nyquist rate, minimum sampling rate, that should be 7000 samples per second. And similarly, we can write some other frequency signals according to the given problem. Now, I am taking one more problem here. The modulating signal is 2 cos of 100 pi t, right. So one signal is given here, sinusoidal signal. Modulating signal or message signal is 2 cos of 100 pi t. Then the Nyquist rate of the given signal is, this is the question now, Nyquist rate of the given signal. So to find the Nyquist rate, first of all we have to find the maximum frequency of the information or maximum frequency of the message signal. So for that purpose, just I am assuming this signal is defined like this from the standard sinusoidal signal equations, a cos omega mt, right. So from this, what is omega m here? Omega m is 100 pi radians per second, right. Omega is nothing but angular frequency. So angular frequency is 100 pi radians per second. Then I want from this frequency, so right angular frequency is like this, 2 into Fm is 100 pi. then the maximum frequency of the modulating signal is here 50 hertz. Okay, so maximum frequency is 50 hertz, and if you want to write the maximum angular frequency, that should be 100 pi radians per seconds. So in terms of radians per seconds, what is the maximum value here? 100 pi, and in terms of hertz, this should be 50, right? Then we want Nyquist rate. Nyquist rate is equal to 2 into Fm, that means it becomes now 100 hertz. So from the given signal, the Nyquist rate of the signal is 100 hertz. So if you want to write in terms of radians per second, write multiply with 2 pi, then which gives the in terms of radians per second. That is depends on the given question. So here we want the Nyquist rate in terms of hertz. That's why I wrote like this here, right? So one signal is given 2 cos 100 pi t, and one more signal I am taking now. That signal is, let us write like this, m of t is 2 cos of 100 pi t plus pi by 4. Okay, one more signal is defined like this here, right? So 100 pi t plus pi by 4. Plus pi by 4 means the complete signal is shifted towards the left side pi by 4 times. So any constant adds with this angle, then it performs the shifting operation. That is time shifting. So if it is here plus 5 by 4 is there, that's why this cos signal is shifted towards the left side here, from this analysis left side, and if it is minus symbol, the signal is shifted towards the right side, that is advanced signal or delay signal. Depends on the symbol, we can write different analysis, right? So the shifting operation does not affect on the Nyquist rate. See, if you shift the signal towards the right side pi by 4 times or towards the left side pi by 4 times, frequency of the signal should be as it is. There is no changes in the frequency, right? So if the frequency of the signal is not changes, Nyquist rate also not changes, sampling rate also not changes. This is also one of the important point here. Shifting does not affect on. Shifting operation does not affects on sampling rate. Okay, so the shifting operation of the signal does not affects on the sampling rate. This is one of the important point. And one more signal I am taking now, the x of t signal. This is m of 2 into t. M of 2 into t. That means 2 constant multiplies with the time axis. If any constant multiplies with time, then it is called time scaling operation, right? So if the 2 is multiplies with t, then the resultant signal becomes now 2 into cos of 200 pi t, right? So here this complete angle multiplies with 2, then the frequency becomes now 200 pi, right? That means time scaling operation affects on the sampling rate, right? Time scaling operation affects on the sampling rate. See how much sampling rate here? From this we can write Fm is 100 hertz and sampling rate is a Nyquist rate. Generally I am writing here Nyquist rate is 2 into 100, that is 200 hertz. So before that scaling operation, here the Nyquist rate is 100 hertz, now it becomes a 200 hertz. So time scaling operation affects on the sampling rate. From all this, I want to write some standard equations here, right? Those equations are like this. The Nyquist rate of x of t is, just I am writing Fs, let us assume it is Fs. Nyquist rate of x of t signal is Fs. Then the Nyquist rate of x of t minus t naught, or t plus t naught, that means the signal is shifted towards the right side or towards the left side. If the signal is shifted towards the right or left side, it does not affect on the Nyquist rate. So there I wrote Fs only. So shifting operation does not affect on the Nyquist rate or sampling rate, right? And if the signal is multiplies with a into t now, right? So here 2 multiplies with the signal, so time axis, then the Nyquist rate is increased by 2 times. So similarly, here A multiplies with the time axis, the Nyquist rate is increased by A times. So now the Nyquist rate becomes here A into Fs. So time scaling operation affects on the Nyquist rate, time shifting operation does not affect on the Nyquist rate. So these are the some important points, right? One more example I want to take now. 2 cos of 100 pi t plus 3 cos of 200 pi t. Okay, let us take 3 sine or cos, anything. Sine, cos, it does not, because shifting does not affect on the sampling rate. So 2 into cos of 100 pi t plus 3 into sine of 200 pi t. So 2 signals are there. This signal consists summation of the 2 signals. One signal is cos 100 pi and other signal is sine 200 pi. So this complete signal, this signal consists 2 different frequencies. For that purpose, individually I am finding individual frequencies of the signals, right? So maximum frequency of the first signal is 50 hertz, because here we have to divide with 2 pi, because this explains the omega from this analysis. So directly I am writing there, right? And here sine 200 pi t is there. So maximum frequency of the second signal is how much here? 100 hertz. So maximum frequency of the first signal is 50 hertz and second signal is 100 hertz. 2 different frequencies are there. And according to the sampling theorem, here we want FM. FM is the maximum frequency of the message signal. So now the message signal consists 2 frequencies. From this we have to take always maximum frequency. So FM is equal to maximum of FM1 comma FM2. So from these two, any one frequency, that frequency should be maximum frequency. Then we have to take here 100 hertz. From this write the Nyquist rate now. Nyquist rate is 2 into FM, that becomes now 200 hertz. Okay, 200 hertz. So now from this analysis, from this problem, I want to write some other important formula here, right? So those formulas should be like this. Let us consider one x1 of t signal sampling rate or Nyquist rate. Just I am writing here. Nyquist rate of the x1 of t is f1. Okay, let us write fs1. Right, and some other signal I am taking now x2 of t. Nyquist rate of x2 of t is fs2. Okay, otherwise not Nyquist rate. Let us write maximum frequency is better. Maximum frequency of the first signal is FM1. Okay, and maximum frequency of the second signal is FM2. Just I am taking maximum frequencies. Right. So one signal maximum frequency is FM1, another signal maximum frequency is FM2. Then I want to find maximum frequency of x1 of t plus x2 of t. Right. So I want to write the maximum frequency of summation of these 2 signals. Individually the maximum frequency of this one is FM1 and second signal maximum frequency is FM2. Now these 2 signals are added. Right. So these signals are added, then what is the maximum frequency of the resultant signal? So that purpose always we have to take this equation here. Maximum frequency of this is maximum of FM1 comma FM2. Right. So maximum frequency of, let us write this is equal to FM. Maximum frequency of the summation of the 2 individual signals are maximum of FM1 comma FM2. Similarly, now I am taking the product of these 2 signals. Product of these 2 signals. Now these 2 are multiplied here. x1 of t signal multiplies with the x2 of the signal. Then I want to write what is the maximum frequency of the product signal. Product of these 2 result signal, right? So that purpose which gives the FM is equal to FM1 plus FM2. So if the 2 signals are multiplies, then the maximum frequency is summation of the individual maximum frequencies. And if the 2 signals are adds here, If added, these two signals are added, then the maximum frequency is maximum of any one. So FM1 comma FM2. So these are some standard equations. To find the maximum frequency of the given signal, we have to use this formula here, right? So product purpose. Let us take here the sine function, cos function, both are multiplies. From the trigonometric equations, we have one standard equation: 2 sin A cos B. 2 sin A cos B is sin of A plus B plus sin of A minus B, right? If suppose 2 cos A cos B, cos of A plus B minus cos of A minus B. So like that we can write A plus B, A minus B. So we want a maximum, so we have to consider plus condition. That's why whenever the two signals are multiplies, so maximum frequency is FM1 plus FM2, summation of the individual maximum frequencies. So just here I have explained how to find the Nyquist rate for the different methods, from the different methods of the problems with the single signal and summation signal and product signal. Okay. Please take this now.